Hello everyone, this is Yuwei and I'm going to share a short survey about the batch RL in the real world. Recent years have seen a huge success of RL in many challenging problems. Most of these examples are from the game domain, where we can easily collect millions of samples. But in many real-world problems such as healthcare, robotics, or self-driving cars, it is usually costly, time-consuming, or dangerous to interact with the environment. Thus, in these domains, we can hardly collect enough data online to train an RL algorithm. Batch RL, or known as offline RL, has been viewed as one of the most promising solutions to this challenge. Batch RL refers to learn a near optimal policy from fixed dataset without interactions with the environment. Some early work divided batch RL into two settings. Unlike the pure batch setting, in a growing batch setting, the agent is allowed to occasionally interact with the environment to collect new data. Here is a crude classification of batch RL algorithms. Fitted queue iteration and its later variants such as an FQ and a DFQ are most representative classic batch RL algorithms. Most of modern batch RL algorithms are model-free methods. Many different approaches have been proposed, such as imitation learning, using policy constraints, learning pessimistic value functions, and using ensembles. In this work, we aim to connect current research work with real-world applications and will introduce different examples of applying batch RL to real-world problems. First example is the robotics. Collecting large amounts of data with real robots may be time-consuming, and they all suffer from wear and tears that is expensive to repair. Thus, learning from collect data with batch IL is appealing for robotics. One of the most famous applications is Robot Cup soccer leagues. Early works developed fit iteration-based robots to learn various mobile control skills. They use simple two-layer MLP to learn effective strategies. A recent example is the reward sketching, a data-driven approach to apply DRL to learn perform manipulation tasks on real robots from vision. Learning a chatbot has been an active research area in HCI domain for decades, and batch RL has been applied to learn chatbot for a while. For example, Piquin proved that batch RL methods like FQI and LSPI are sample efficient to learn near optimal policies from few hundreds of simulated dialogue examples. More recently, KL Control learned neural chatbot from fixed dataset by constraining the learned policy to stay close with the language model. The third application is energy management system. Current modern power systems, especially those involve renewable energy, require advanced control techniques. Many early works have shown that FQI to be effective to solve some power system problems. For example, Nagy applied DFQ to control space heating in buildings. She applied LSPI-based method to solve LTC problems in power distribution systems. Healthcare is another important application of batch RL, since patient safety is always first priority and we can hardly collect enough data. Ernest applied FQI to learn optimal structured therapy for HIV patients from simulated clinical data. Prasad explored the use of FQI to learn ventilator winning policy from ICU data. Batch RL has also been used in many other areas, such as manufacturing and software development. Gabel formalized job shop scheduling problem as multi-agent MDP and learned optimal scheduling policy with an FQ. Harris developed a DQN-based method for efficient software test framework. Though batch IL have achieved many successful in various problems, we are facing many challenges. First is the lack of effective offline evaluation protocols, which is still a very challenging open problem. The second is the unspecified reward function. Since many real-world problems do not have existing reward function, and designing one by hand is very tricky. The third is the offline training and data tryout. Many current batch IL methods usually suffer from unstable performance that is unacceptable for many real-world problems with critical safety concerns. Here's the takeaway of this talk. Batch IL is promising for practical real-world application, and we have seen many successful examples. VTQ iteration and its variant are the most popular choice. Batch IL still face many practical challenges, such as effective OPE methods, missing reward functions, and data child. Thank you.